I'm going to use this presentation that I delivered at Chulalongkorn University in Thailand. Here, I can take that mouse now and go forward with it, now that I know how this thing works, yeah. This was delivered to us in the School of Surveyors and Engineers. Let's see, go forward. How do you go?
Just try left click. I don't know.
Yeah. Okay. Now, again, I mentioned Von Thunen earlier. He calculated the cost of bringing, I'm going to take this thing out. Here. The cost of bringing goods to market. And of course, a lot of the cost of transportation is based on what it is you're bringing. Are you bringing lumber? Are you bringing fresh vegetables or what? And he calculated the distance, the optimal distance of planting each or using each land type. And he calculated the surface value of each concentric circle relative to the market center of a community, as surface is pi diameter squared. And it works out very well. And here's another version of it, again, distance to market. And you presumably would plant your forest way out in the boonies and have your sheep a little closer and maybe your wheat a little closer and your fresh vegetables even closer. And of course, land value maps were very common when land taxation first was conceived in the late 19th, early 20th century. And these were maps in 1900 in Atlanta. And I won't spend time talking about them in detail, but actually the land value in downtown centers was many times land value just a short walking distance away. That happens to be Atlanta. Here's Columbus, Ohio. Here's New Orleans. Here's New York City. And even in the UK, since you well know that there was a lot of interest in taxing land values 100 years ago and more, this was an actual land value map that was produced for the British Isles in 1901. And of course, it's by county. But nonetheless, it shows the enormous differential value of land. And this was prepared for David Lloyd George. And of course, land elevation is analogous to land value. I mean, you know yourself, if you go hiking in the mountains, you've got isobars that show the elevation above sea level. Well, the same thing applies to metropolitan areas out to the boondocks farming areas. And here is a map that I mentioned yesterday, and Jane would be particularly interested because this is the whole of land value map for New South Wales. And the values per hectare, you can see the highest values are, of course, in the cities, and she could have best identify the cities. I don't know who did this. I'd love to find out. Of course, there's Johannesburg, South Africa, done with a little bit different technology, but you can see the difference in land value from the urban core out to the boonies. And here's...
Bill, could you please credit Godfrey Dunkley with preparation of
I will do so. I didn't know that it was Godfrey Dunkley's
He
work.
contributed quite a bit to it.
Okay. Now here's a case of a visionary town, a city in China. It's going to be called Great City, has yet to be built. They have not used land value taxation, but you can see yourself that they certainly appreciate the efficiencies of putting the most highly invested infrastructure close together and leaving the peripheral areas vacant. Here's another thing of the same type. This is Great City that's going to be built in China. Here's Portland, Oregon. Now they had an urban growth boundary around the city, which was to protect some of the farmland that was threatened. And in this case, farmers wanted to protect their farmland, not to sell it for a gain. And ultimately, the Portland the urban growth boundary collapsed because ultimately people decided they did want the gain. But you can see what the land value, what the urban growth boundary did. It really concentrated the land value in the urban core. The people inside the boundary loved it. Their prices skyrocketed. And of course, there's the case of Salt Lake City. Again, downtown has land value many times higher than the periphery. And you know yourself, just looking at the skyline of any city, that the urban core is going to have much higher land values, which of course fosters the investment of greater capital infrastructure, more buildings. And it's obvious, no matter what city you look at throughout the world, you know where the highest land values are. There's Boston, there's Charlotte, North Carolina. Again, here showing the relationship between elevation from altitude above sea level and the altitude. Here is one of the best land value maps we could have. It was done by one of our Georgist assessors, now retired, Ted Gortney, who was the assessor for years in the Gold Coast of Connecticut, Greenwich. That's where all the hedge fund leaders and movie stars and all that live. And unfortunately, the legend is below this screen, but the land down at the bottom by the sea level here, that's $1,305 a square foot. And you can go up to the top of the,
Sorry, I was trying to help you get the legend, so go back.
no, that just go, it doesn't really matter.
Okay.
Just go back, if, maybe I can get it back here. No, that does,
Previous.
Previous, slide to previous.
well, let's see if I can get it here. Let's see, previous.
There you go.
Is it on there still?
Yeah.
Okay, up here, 5 miles away, inland, the land value falls to less than $5 a square foot. In a distance of 5 miles, $1,305 a square foot down to $5 a square foot. Anyway, that gives you a sense. Here's a lousy land value map. In other words, the assessor in New London, Connecticut had no idea how to value the land versus the building. And he just arbitrarily divided it, and you can see when you make a land value map as a result, the land value per parcel are almost like confetti scattered on a map. Whereas if he had used good, clear understanding of land gradients, he would have done a much more accurate job. In fact, assessors differ. When I've talked with assessors, some are extremely grateful for helping them, give them another tool so they can do their job better. Others are very threatened. And I can understand why, because I think ultimately we will be able to eliminate assessors entirely and just do all the land value by triangulation algorithms and GIS and do it without reference to buildings, and it will be far cheaper. I might add that even GIS is getting much easier to use. I made my first land value map in 1995 because one of the biggest GIS companies across the river from me was Map Info. You likely heard of it. It's now been bought by Pitney Bowes. Map Info was devised by a couple of hotshot graduate students at RPI. Anyway, later the biggest company became Esri, which you know makes ArcView. But now, just like Microsoft suites have been essentially supplanted by open source software, particularly OpenOffice, and other software is becoming freeware. We now have a GIS program called Quantum GIS. And there's going to be a workshop at the Henry George School in Manhattan probably next month. We're not sure of the date. And the professor is a very committed Georgist, now having finished his doctorate at NYU. He teaches at Dartmouth College. And Lee Hachatourian says that he can teach people to use GIS using quantum very easily because, frankly, he says it's as simple as spreadsheets. It's really become very different. So I'm looking forward to learning. I gave up on MapInfo after one map and decided it was easier to get other people. Now, here's another GIS map of a city just 30 miles north of me. That's where the Saratoga racetrack is. And the city, you can see the gradients of land value are very different. And again, this is based on the assessors. If the assessors had used GIS, they could have even refined their map much better. Here's the downtown. You'll see that it's better, but they still could have used the help of a GIS program to make a very smooth land value gradient from center to periphery. But you still see the gradient differences between center and periphery, even using the eyeball assessment where they knock on your door and ask, you know, how many bathrooms you have and how many garages and so on. And then they interpolate what should be land value, what should be building value. The traditional property tax really needs to be replaced because then we could do assessments of land alone. It would be far, far cheaper. A colleague friend of mine in New York State told me that as a rule of thumb, and he told me this 10 years ago, to assess one parcel in New York City, the actual value was $100 a parcel. Upstate New York was $65 a parcel. If we could just get all the data into a database, we could do it for pennies. Far more accurately, far cheaper, and with greater transparency. Anyway, here's another city, Elmira, New York, again based on eyeball assessment. And essentially what they've done is they've subtracted the building value and the residual is the land value. Ideally what we should do is we should assess the land value first and then the building should be the residual. But they don't see that. Here's another city just about 10 miles north of me. Again, they didn't have the advantage of GIS in making the map, making the assessments. All they did, I simply took the data that they had, the assessment roll called a cadaster, and I just calculated the land value per square foot and knew the size of the parcels, and we put it on a map. Again, there's my city of Albany, New York, and you can see where the state capitol is. Down here, you would, in all the office buildings, lawyers, lobbyists, and so on, it should be the highest land value, and along the highways going out of the city. But why in hell is this parcel out here so valuable? Or this one out here? Obviously, the assessor didn't know what he was doing. Moreover, this is the slum area of Albany. All derelict homes that are essentially boarded up. We should write off those parcels, but this land in here is extremely valuable. Obviously, they got it wrong. Anyway, there's a refined map of just the downtown. There's Polk County, Iowa, where we had a conference at one time, and this land over in here, Des Moines is the capital of Iowa, that land goes as high as $31 million per acre. And this is the downtown, but if you go out here, these are cornfields and vacant land, whatever, except for this area, which was a shopping mall. Essentially, this land is farmland. And even here, a lot of it is floodplain. That's where the white is. But you can see for the whole county, Polk County, Iowa, the differential in land value is enormous. And that just shows you how much the gradient can be. This is Tompkins County, where Cornell University is. This is the first land value map I ever made and the only one. Tompkins County is about 30 miles across. The red here is the downtown in Ithaca. This is where Cornell is again. And that highest value parcel was over $1 million an acre. And it went, unfortunately I didn't put it on here, down to about 56,000. And you notice the yellow way out in the boonies falls to less than $3,000 an acre. And if you really want to see something interesting, take a ratio of land value to total value, and you can see, ideally, if we had efficient land use, we would have high value buildings on high value land and no buildings on no value land. But no, given the system we have, a lot of wealthy people have put their nice homes out in the cheap land, especially a lot of wealthy professors at Cornell. Beautiful views, but what we've got is a beautiful example of sprawl development. As I said, if we had efficient land use, all of this would be one color. This is a ratio. And you can see yourself, this is another version of Van Thunen's map. In the urban center, you've got high value land and low costs of transportation. At the periphery over here, you've got low value land, high costs of transportation. Yeah. And the cost of infrastructure or a car is the same no matter where you live. And these are maps done way back in the 1930s. At the time, making land value maps was very expensive, but they knew about it then, but it was so labor intensive, essentially they abandoned the idea. This is Boston, where a guy decided he wanted to decide where to rent an apartment. And the land value, which determined lots of the rental of apartments, was a function of the transportation services in Boston. There's a map that I did about 10 years ago showing that we could have paid for an interstate highway going from the edge of Albany up to Montreal 11 times over, given the added increment of land value within 2 miles on each side. We could have captured that value. It's called, by transportation people, value capture. In New York City, the Federal Reserve Bank economists took the arm's length sale of vacant parcels, calculated the cost per square foot, and made a map. And this is totally based on sales, bypassing assessors altogether. Downtown Manhattan, the value per square foot reaches as high as $12,647 an acre, down to about, per square foot. You're right.
$12,000
Yeah,
square foot.
Right, but if you just go a little way out into Jersey, you find that the land value falls, based again on sales data, to less than $2 a square foot, which shows how much we can do just using computer technology and not even bothering with assessors. We probably could use triangulation algorithms and get the land value per square foot for all of Jersey and all of New York. And in fact, we're working on it now. Not all cities are monocentric. This is Akron, Ohio. Again, land values really vary by neighborhood. And this map was 2007. It shows the progress we're making in having polygons, that is demarcation of the parcels of every single parcel in the state and county. And I think by now, 2013, it's all done. The whole state could be mapped. This again is totally electronic. This map was done just by computers of Louisville, I believe. Anyway, that's the last one. It gives you a sense of the potential. I got every one of these plus lots of others on a thumb drive if anybody wants it.
I invite you to have the tea break with Bill, those who want to talk on this subject. Thank you, Bill, for bringing it up. The only change I would make in your presentation is this. When you refer to those of us who live in the wonderful, beautiful countryside, that it not be called way out in the boonies. I would never, if someone asked me where I live, say, I live way out in the boonies. So the past few years, we've had tiny bit of funding from the IU and from the Schachenbach Foundation to do some pilot projects in both South Africa and Nigeria on what we now call research for land value tax policy implementation. Now, the whole string of words means that we intend to implement the policy. That's the goal. But we're doing the research so that we know specifically how to recommend, build populist movements, educate, and inform political leaders on how to, specific to that situation of that town or that country, implement land value tax policy. The GIS land value maps, as I think you can appreciate having seen Bill's presentation, are going to be crucial. But we layer these. Now, he saw the dots on that. What we're able to do now with the emerging technology is click on one of those dots. We want to then map the specific land value of that parcel, and then who owns that parcel, or who's responsible, who claims that parcel. So if there's conflict over a parcel, we're going to be able to also see what kind of mediation we need to solve the land tenure conflicts. Once we know the land values on the maps, and it'll be very transparent and on the internet, and it'll drive the movement for implementation, we can then calculate how much percentage of land rent will pay for the basic social, political needs that the community already has, how, by other taxes, to shift taxes off of labor and production. We'll be able to do all sorts of modeling, and this will drive our movements. Now, in thinking through how to organize, there's really an obvious way to organize, and that is geographically. So for instance, right now, the IU, we're having 1 or 2 vice presidents per country. Our policy now is once you have 15 people enrolled, you have a vice president, another 15, maybe a second vice president, but maybe we limited it to 2 vice presidents for a country. We're going to get an unwieldy group of VPs. But then I would suggest that those who are organizing and representing the IU as vice presidents develop their own way to develop leadership, and however you would then divide up your country in terms of leadership in the movement. And you just would keep that transparent. So obviously way is just to organize by countries and regions within the countries and develop leadership and education that way. The other way to organize, I would propose, is by specific interests. So those who are academics around the world would form networks. The great idea of taxi drivers around the world forming their network. Everybody who has a particular interest, you would globally form an organizing group. It might be people who teach literature and want to interface with some very fine literature that looks at economic justice. I mean, there's no end to what we can form kind of interest groups, and trying to give you a flavor for this. But all of them would have the focus in the end of the land value tax policy implementation.